Hi friends, welcome back. Today we have another project on supervised learning. So this is basically a project on marketing again, but this time we will be applying naive Bayes k nearest neighbor and support vector machine algorithm in this project, right? So basically the objective again is to predict customers response to a particular product with the help of variety of classifications model like naive Bayes k nearest neighbors support vector machine on the marketing campaign data. So if we talk about the detailed problem statement, it was given that an e-com company has recently run a marketing campaign around the customers. The company has collected various attributes regarding its customers like education, marital status, country, and various data regarding the amount of money they spend on buying products for the company's website. Right now, for the launch of a new product, companies want to know whether the customers will respond to that product or not. So as a data scientist, what we do, so we will predict if a customer will respond to a product or not, right? So let's start with each and every step. So first it is asking that just load the data and do the exploration of the data. So first thing we are going to do is to import necessary libraries. Again, all the libraries that we are gonna use in our project: NumPy, regular expression, pandas, stats, right, matplotlib, seaborn, mathematics is there, pylab is for RC parameters. Then we are defining RC parameter of 10 by 15, then model selection to get the twin test split, right? Multinomial naive Bayes for naive Bayes classifier, then k neighbors classifier for k nn, and SVC for support vector machine. And again the reports from the matrix like right, like classification, confusion matrix, ROC curve, that we have already seen in the last video. So last thing here, one thing again, that is font properties, again that we are getting from font manager. Now second is display a sample of 5 rows of the data frame, right? df equal to pd.read csv. So it is marketing data csv, that is the csv we are using, and I'll be providing the csv link in the description as well, right? So you can get it from there as well. And df dot sample, that is n equals to 5. Okay, so here basically the sample we are checking with 5 samples. So just you put the sample, so it will pick random data from your data frame. Okay, and next thing it is asking that check the shape of the data, number of rows and column, check the general information about the data frame using info method, right? So basically again we are defining a method, that is basic info method. It will take df as our data frame and it will check the basic information and shape about data and return that. Okay, so here you can see that we are passing df here, where it is taking a temp of our actual data, then printing the shape of data frame, right? This is nothing but for styling we are printing asterisk 30 times, and after that we are printing the information of our data frame. So here you can see that it has printed the shape of data, where it is the number of rows and column, then the asterisk for styling, and finally the information of our data frame. So here you can see that all the attributes are here and their respective values and the non-null or null columns, right? The data type is also there. So you can see that we have integer data type, we have object data type in our data frame, right? Fourth thing, it is asking that check the percentage of missing values in each column of the data frame, drop the missing value if there are any, right? So you can see here we are again defining check missing values df. So here function to check the missing data percentage, again we have also seen it in the last video as well. So how it will calculate that, it is getting df dot is null, right? If there are is null value, just get that, just do sum of them and divide them by length of df to get the percentage, and finally multiplied with 100. So here you can see that we have given the data frame, and then we got the percentage of null values. So in income you can see that there are null values, right? So this is basically the same data frame that we have used in the last video. You can either use the same one, right, because half portion of that analysis is same, but I'm telling it from starting so that you can quickly revise it or get a better understanding with it. So again here you can see that only 1% missing data in the income column. That will be directly we will use drop any function to drop the missing values. So here you can see that we are just dropping the missing values, right? X is equals to 0, in place equals to true. So 0, that will delete all the rows, and rows will be deleted permanently. Now checking missing values, so passing df here, right? Again it is returning all the missing value if there are any. So we normally calling the function here. You can see that once we have defined it, we can call it time to time. And finally it is asking that check if there are any duplicates rows. So again, to check the duplicates rows, we can do either by directly applying this formula or just making a simple function and call it when we require it. So I'm defining a function that is check duplicate df. So duplicate equal to df dot duplicated, where return is duplicate, so it will return all the duplicate value. Now duplicate equals to check duplicate, again passing the df. So here you can see that there are no duplicate value in our data frame. Sixth question, it is asking that remove the extra spaces in the income column name, right? So extra spaces, that means we have to use the string dot replace function here. So this is the space and we just cutting the space from here. So this is the remove space function which will help to remove spaces from the name of column, passing the df in this function, and it will return a new df which will have no spaces, right? Seventh step is check the data type of value in column income, convert the value in the income columns to numeric format. So what we will do is we are defining a map income again here, right, which will map all our values. So in which we are taking x, so x dot strip, we are checking if there are any such values, right? So it will remove that. And secondly, x will regular expression, it will check the values, like if there are any space, just separate them using comma, right, and it will apply in the all x. So finally in except block, if there are any exception, I mean the code is not here, so it will normally print that none. Okay, so now the df dot income, we are applying that in income attribute, and applying the map function in income, that is map dot income. Okay, so next step is check the basic statistics of data frame using describe method. So defining basic statistics df, right, and returning the describe function that is in transpose. So finally you can see that we are calling the basic statistics function here and passing the df here. Ninth is write a function which will take the data frame as input and will plot a bar plot which represents the percentage of distribution of each level of country column, right? So here we are defining a function that is a percentage country, and it will take a df, that our data frame. First we are taking a copy of our data frame, right? Then we are defining a variable cu data which will contain the data of country, right, all the value counts of country data. And secondly cu data, in which what we are doing is we are taking the frequency percentage here, right, defining a new column frequency percentage which will get the percentage of this country that we just got the cu data, right, and it will be stored in our frequency percentage. Finally we print the cu data, so it will print like a data frame. So you can see that each country has their country name, code, and percentage, frequency percentage. Secondly, ax, that is nothing but, now this is for our plotting our graph. So here we are using bar graph, defining the size, color, font size, width and all, right, for country only. And secondly we are setting the title for it. So the title will be percentage of country data distribution, and font size we are providing 14, and the totals we are taking an empty list, right, and now we are applying four functions, for loops. First is for I in ex dot patches, which will append the width of our I into this total list, right? And secondly, for p in ex dot patches, which will define or annotate as in ax dot annotate str. We are taking round p dot get height, right? So it will define height of all our bars, right? And at the top of that we are providing percentage of each country, right? Each country distributions. So here you can see that, and ax dot set y label we are providing count, and font size is again 14. So now you can see that this is count, this is percentage of country data distribution, right? So SP is here, SA is here, CA is here, A US Australia, for India Germany, right? So the highest percentage you can see that is for SP, right? So that is percentage of country data distribution, and count is for it is 91%. 10th is plot a bar plot which represent all the qualification of the customers country wise. What is the percentage of graduates in Spain, right? So again for this question it is asking we have to plot the graph again and get that what is the percentage of graduate in Spain. So for that we are defining a function cross country education percentage, passing the df here, right? Taking a copy of our main df, right? Country dot cross tab percentage, so it will take the percentage of education country and applying lambda, that means for each and every country, right? With the education field. And secondly printing the country cross tab percentage, right? So it will print this table first that we just got from this line, right? And then it is printing asterisk 70 time, right? For styling you can see that. And then ax dot country, so the chart portion starts from here, right? So first we are plotting a bar chart, right? Figure size is 20/8, color is this one, right? Axis dot set title, so percentage of frequency of graduate in different countries. So font size we are giving 16. Totals that we are providing again having an empty list and doing the same equation here that we have done in last tab, right? So here you can see that this is the equation that will take this graph patches and define this percentage at the top of our each and every bars. So the same thing we are doing here, but this time you can see that it is colored with different colors. So here because we have already defined our colors here, right? So it will take color for each and every country. So here you can see that second cycle for each country it is distinguished with color, but you can see that with each and every attribute our SP country is the top highest rating that has percentage of frequency of graduate in all these countries. So PhD is also having top in SP, masters also having in SP. If we talk about masters, so it is taking here that is slightly ME, right? Graduation again SP is highest, basic again SP is highest, second cycle is SP highest. And when we check for the India, so here you can see that India is 54% in PhD, right? And masters that is in India is 5.4% in PhD, 5.7% in masters, but graduation it is slightly increased up to 6.8%, basics that is 7.4%, and second cycle is 10%, right? So basically it has asked for Spain only. So you can see that 48.92% of graduates are from Spain. So graduates, right? And 48.92 from SP, that is Spain. 11th is plot a percentage segment graph between the marital status and education of customers. So here you can see that these are the font properties, right? Font P dot set size access small, properties that is df dot group by marital status, education, right? Value counts normalized equals to true, and this is for n stack. And properties that we are plotting a bar plot, stacked equals to again true, and legend we are providing performance for title, and B box to anchor, that is the anchor color, that the anchor code that we are providing. Log is upper left, right, and property font p, and finally plot dot show. So here you can see that for every single attributes, and these are the educations, so we are checking marital status for every educations. So if we check for YOLO, so YOLO you can see for second cycle, right? Widow you can see that it is for second cycle. The orange one is for basics, the green one is for graduations, and the masters, that are few widow that have done masters, few PhD that have done few widow that have done PhD. And if we talk about the absurd, so you can see that the masters and the graduation ratio is almost same for absurd, right? 12th point, it is asking that plot a percentage segment graph between the education and country of customers. So again, we are defining font p equals to font properties, font p dot set size, that is again double x small. Properties, we are grouping it by education, country, and getting the value count to normalize it, right? And it is again unstack. And then properties dot plot kind is equal to bar and stacked equals to true. Plt dot legend, that is our title, equals to performance. B box to anchor, that is again 1.05 to 1, that is the range that we are providing. And log, that is again upper left, right, and properties font p. So this time you can also see that education with country, right? So PhD you can see that in unstack method, masters you can see that with respective country, graduation you can see that with respective country, and so on so forth for all the attributes. Now the second step we have is the model building and evaluation. This part is also covered in the last video, right? So if you have already seen that video as well, you can skip this part as well. So plot a count plot of the target variable, right? So you can see that plot target df we are having here, df equals to df dot copy. Okay, so here we are again making a copy here and counting and plotting it as count plot. So here you can see that response variable 0 1, but again you can see that the data is imbalanced, right? So what we will do is we can drop all these columns that are not useful, like id, year of birth, dt, customer, country, education, and this is what exactly we have done in the last video as well. So we are using df dot drop, dropping all the columns, x is equals to true and in place equals to true, right? And then storing the data, storing the target column, that is response, in the y variable, and the rest of the column in the x variable. So y equals to new df response, and df dot drop response, x is equals to 1, in place equals to true, x equals to df new x, that is x dot as matrix, new y, that is y dot as matrix, and new y, that is new y dot reshape, that is -1 and 1. So split the data set into two parts, that is 70% train and 30% test, right, using random state of 42. So x train x test, y train y test, again calling the train test split, right? The function that we are calling is new x new y, test size equals to 0.3, that is 30%, that means test size is 30%, so remaining 70% is our training size, and the random state is 42. Now it is asking that train a Naive Bayes model and plot the blue matrix, right? So finally we are starting with our Naive Bayes. So plotting the error plot for the given alpha. So alpha value that we have already given, that is, or we can take anything that according to you, and choose the best alpha, right? Train the model on the best alpha value, print the accuracy classification report, ROC curve, right, for both the train and test. So let's get started with our Naive Bayes, right? Defining train AUC and test AUC, passing the alpha value, so that we have defined 1 2 3 4 5 6 7 8 alpha value, right? Now starting with a loop, that is I in alpha, so it will render in each value in alpha, nb dot multinomial, that we have taken the Naive Bayes, right, and alpha equals to I, so for every I the Naive Bayes will be executed. Now Naive Bayes dot fit equals to x train y train, that we just got from our train test split, and y prediction train, that is the new variable which will store the prediction of our x train. Similarly, the y predicted test will store the prediction of our x test. Now printing for the alpha value, so it is I. The accuracy on the train data, accuracy score is y train, y prediction train, right? Printing for the alpha value, so again I, right? Accuracy on the test data, accuracy score for y test, y prediction test. And printing star 50 times, then training AUC dot append, so it will have ROC AUC score, that is passing y train and y prediction train, and then test AUC dot append, so it will take ROC dot AUC score, y test and y prediction test. PLT dot plot np dot log 10 alpha train AUC label, that is train AUC, and PLT dot plot np dot log 10 alpha test AUC label dot test AUC. Now PLT dot scatter np dot log 10 taking alpha and train AUC, right, label equals to train AUC points. Similarly, PLT dot scatter np dot log 10 alpha test AUC label equals to test AUC dot points. And then PLT dot legend, PLT dot x label equals to alpha values, and PLT dot y label equals to AUC. And then PLT dot title, that is error plot, right? So PLT dot grid function and PLT dot show function finally we have got. So here you can see that this is the values for each iteration you have gotten, right? When our I was this, then the train data was this. When the I was this, the test accuracy was this, right? And if we compare the accuracy, so you can see that at the time of this one, right, when our alpha value was 1000, the accuracy was 70%, 72%. And similarly for test accuracy, it was 72% when our alpha value was 1000, right? So if we plot this the error plot, so you can see that our AUC, right? So for AUC, this test AUC point, you can see that, right? And for train AUC, that you can see here all these points. Next thing, we are also using now multinomial naive Bayes. So here again passing alpha as 1, right? Y prediction train, that is np dot prediction, we are taking it, and y prediction test np dot prediction x test. Okay, now we are printing the same train accuracy, test accuracy, okay, and again the styling, train classification report, test classification report, again styling, and finally printing the ROC curve. So again for ROC curve, you can see that y train prediction np dot predict probability, x train we are passing, and np dot predict probability x test, right, passing here. Now train FVR, train TPR, TR dot threshold, you can see that ROC curve, y train, y prediction, okay, and from 0 to 1 minus 1 sorry n minus 1, and test FPR, test TPR, test threshold, ROC curve, y test, y prediction test, predict, right? So again taking the indexing values. So again here we are applying the slicing here, taking all rows but keeping the column, that is 1 for column, right? And similarly test FPR, test TPR, test threshold, we are doing the same thing, right? ROC curve and having y test prediction of all columns. Okay, now PLT dot plot train FVR, train TPR label, so that is train accuracy string we are printing, and then converting this value into a string, right, which can be appended. Finally we are labeling it as x label threshold, y label AUC, title AUC plot. Now the train accuracy, you can see that is 72%, accuracy score of test is also 72%, and this is the classification report, right? So precision, recall, F1 score, you can see that. And at the time of second iteration, hope you can see that, where we are passing it for test, right? So this is for test iteration. So for test, you can see that the accuracy score that we got. And finally the printing ROC curve, that is the AUC plot. Okay, so here you can see that the blue that you are seeing here is a train AUC basically, which is 68%, right? And the test accuracy is the yellow one, which is 69%. Second, now it is asking that train a k nearest neighbors classifier model and plot the blue matrix. So again plotting the KNN this time. So plot the error plot for the k nearest neighbor models on the given k values. So that is k value equals to 3, 5, 6, 9, 11, 13, 15. Find the best k, right? Train the model on the best k values. Print the accuracy score, classification report, ROC, AUC curve for both the train and test. So let's get started with this point. We are again defining our train accuracy and test AUC, right? And train AUC and test AUC, and then k value that we have already given. You can also try with different k values and check where the it is giving the best results, right? So again we are using that in an iteration. I in k values, knn equals to k neighbors classifier, n neighbors equals to I, knn dot fit equals to x train, y train, y prediction train equals to knn dot predict, that is x train we are passing, y predict dot test that equals to, that is knn dot predict, x test we are passing. Print for the k values, right? I we are passing here the accuracy on the train data, that is accuracy score, y train, y prediction train. For the k value I, accuracy on the test data, accuracy score, y test and y prediction test. Printing asterisk 50 times. Train AUC append ROC AUC score, so y train equals to y prediction train, test AUC append ROC AUC score, y test, y prediction test. Now plt dot plot, we are plotting k values, train AUC, right? And passing label as train AUC. Similarly plotting for test AUC, right? K values for test AUC and label test AUC. Then scattered for k values, train AUC, label equals to train AUC points, right? So scattered, that will scattered like you can see all these points. And similarly scattered for test AUC as well. Legend, right? Calling the function x label, we are passing k values, AUC we are giving, error plot we are giving for title, and plt.grid and plt.show. So first you can see that grid is already here, right? Grid with plot is shown here. But before that, let's check the accuracy. When our k was 3, right, the accuracy on the train data was 89% and the accuracy on the test data was 82%. Then when the k value was 5, the accuracy on train was 87 and the accuracy on test was 83. Now it is slightly decreased here. Next step, it is also decreasing here, it is also decreasing here, decrease. So you can see that in our case 3 is the best k value that we can achieve here, right? So if we check the error plot, so you can see that again the blue one is for our train AUC, right? So this is the accuracy, and the test accuracy you can see that is the yellow one. Now what we are doing is we are taking the n neighbors as 7, right? K neighbors classifier as 7, which is giving us 86% of the accuracy. Here you can see that 86%, and we have done the same thing again, defining each and every values, but this time we are printing the classification report, right? For any value we can print that, and 86% the accuracy is it is giving for accuracy, and 84 is for test accuracy, right? And this is the classification for train accuracy. You can see that precision, recall, F1 score and support values. Similarly the classification report for test accuracy, precision, recall, F1 score and all. And finally the ROC curve. So here you can see that the blue one, that is our train accuracy, and the yellow one is our test accuracy. So this is 66% and this is 86%. And this is a threshold that we have defined from 0 to 1, right? Now train a support vector machine, the third algorithm that we are doing, and is the final algorithm of this video. So here we will apply support vector classifier, right, model, and plot the blue matrix. So plot the error plot for the support vector classifier model on the given C values. So C values is nothing but in this list you can see that. Find the best C. Now train the model on the best C value, print the accuracy score, classification report, right, ROC AUC curve for both the train and test. So here you can see that train accuracy, train AUC we have, and test AUC we have an empty list. Then we are defining our C value for SVM classifier, right? Again iterating I in all the C values. SBC we are calling this support vector classifier, right? Width we are passing as balanced. Weight we are class weight we are passing balanced. C is our I, right? SBC dot fit we using this X train and Y train. Y prediction train equals to SBC dot predict X train, and Y prediction test SBC dot predict X test. Now printing for the C values, right? I the value currently we have, and the accuracy on the train data will get the accuracy score of train data. Similarly the accuracy on the test data will give the accuracy of the test data. And finally printing the 50 time asterisk again. Now train AUC dot append equals to ROC AUC score Y train and Y prediction train. Test AUC dot append equals to ROC AUC score Y test dot and Y prediction test. And finally we are using the plotting. So you can see that our SBM for when the C value was 0.01, so the accuracy was 66 for train, right? For test it is 64, and it is increased when it was 0.1, right? It is also increased when it was 1, increased when 10, increased when 100, and increased when it was the highest when our train accuracy was 100, right? It was 77%, and the test accuracy was 76%, right? So the C value was 100 at that time. Now if we plot our error plot, so here you can see that our train accuracy points, right, and our test accuracy, our train accuracy points and our test accuracy points, right? So it is how the C values is defined here, and the AUC you can see here. Next thing, we are taking the C as 100, right? So we will print the classification report for this value. So again SVC equals to SVC dot C equals to 100, class weight is balanced, probability is true. So this time again we are applying the same thing that we have done earlier, but here we are also printing the ROC curve. So for ROC curve, first you have printed the classification reports here, right? For train test, train data and test data, and then the ROC curve. So the ROC curve, that is Y train prediction SBC dot predict probability X train, Y test dot prediction SBC dot predict probability X test, right? And then the train FPR, train TPR, TR threshold, ROC curve. So Y train prediction, right? So it will take all the columns. Similarly for test FPR, it will take ROC curve for all the column, right? Then we are plotting that, okay, passing the X label, Y label, and the title. So this is what the classification report. Again the accuracy for train 77% and accuracy for test 76%. The classification report for precision, recall, F1 score, and SPM, right? So here you can see that all these values. Similarly for test accuracy. Now AUC plot. So here you can see that these are the train AUC and these are the test AUC that we have, right? So I hope you got the slight idea about naive Bayes, KNN, and SVM, that how we performed all these three algorithms inside one data set. So you can also check with other values for KNN, other values for SVM to get the best result at your end, right? So yeah friend, hope you enjoyed the video of the projects, right? And hope it is helping you to having better understanding with all the machine learning algorithm, right? All the supervised learning algorithm. So stay tuned. If you like the video, please do like, share, comment, right? And share with your friend also, so that they can also get benefits from it. Okay, so have a good time. Thanks for being with us. We will come up with next video very soon.